So in today's video, we'll be discussing about chapter 5 of ACE level chemistry, that is the physical chemistry, that is chemical energetics. And we have already discussed these chapters. You can find these videos in the playlist. Now we will discuss chemical energetics. So chemical energetics, that is from physical chemistry. So what is enthalpy? So enthalpy is the total heat energy content of a system. So enthalpy is the total heat energy content of a system, or the total amount of heat energy of a system. So enthalpy is the total amount of heat energy of a system. Now what is enthalpy change? So enthalpy means the energy, and enthalpy change means the energy change, that is change in heat energy content of a system. So change in heat energy content of a system measured at constant pressure. So enthalpy change is denoted by delta H. So enthalpy change is the change in heat energy content of a system. Enthalpy change is the change in the heat energy content of a system. Then what is endothermic reaction? So for endothermic reaction, heat energy is absorbed during a reaction. So heat energy is absorbed during a reaction. So for endothermic reaction, heat energy is absorbed. Suppose this is our system and heat energy is absorbed during a reaction. So for endothermic reaction, heat energy is absorbed during a reaction. And since heat energy is absorbed, so delta H, that is the enthalpy change, is positive. And enthalpy change is calculated by the formula, that is enthalpy change is equal to enthalpy total energy of the product minus total energy of the reactant. So enthalpy change is calculated by the formula, that is the total energy of the product minus the total energy of the reactant. So for endothermic reaction, heat energy is absorbed, and for exothermic reaction, heat energy is released. So for exothermic reaction, heat energy is released. So heat energy is released during a reaction, and so for exothermic reaction, delta H, that is the enthalpy change, is negative, and for endothermic reaction, delta H, that is the enthalpy change, is positive. So for endothermic reaction, since heat energy is absorbed, so absorbed is positive and release is negative. Absorbed is positive and release is negative. That is the enthalpy change when energy is absorbed is positive, and enthalpy change when energy is released is negative. So this is the energy profile diagram, that is the energy against progress of reaction, or just energy against time graph. So for endothermic reaction, we know that heat energy is absorbed. Since heat energy is absorbed, so product would have more energy compared to the reaction, and this arrow is denotes that it is activation energy. Activation energy is the minimum amount of energy for a reaction to occur, and this is enthalpy change, that is the energy of the product minus energy of the reactant. Then for exothermic reaction, we know that energy is released. Since energy is released, so product have low energy compared to the reactant. Since energy is released, so product would have low energy compared to the reactant, and this is activation energy, that is the activation energy. And enthalpy change is this arrow, and it is always directed towards the product side. So enthalpy change, this arrow is towards the product side, and the enthalpy change is towards the product side. So energy against time graph for exothermic reaction, and this is for endothermic reaction. Now for standard condition, so for standard condition, there is standard pressure and standard temperature. So pressure is 1.013 into the power 5 Pascal. Pressure is 1.013 into the power 5 Pascal, and temperature is 298 Kelvin or 25 degrees centigrade. So temperature is 298 Kelvin or 25 degrees centigrade. So standard enthalpy change of reaction. So what is the standard enthalpy change of reaction? So enthalpy change is denoted by delta H, and since it is the enthalpy change of reaction, so reaction. So standard enthalpy change of reaction is the enthalpy change or the energy change when the amount of reactant react to give product under standard condition. That means basically reactant forming product, and this is enthalpy change of reaction, and it have to be standard. Standard enthalpy change of reaction means that at standard condition of temperature and pressure. So standard enthalpy change of reaction is the enthalpy change when amount of reactant react to form product under standard condition. So reactants react to form product, that is hydrogen plus oxygen is equal to water, then hydrogen plus oxygen water. So in both of this reaction, reactants are reacting and product is forming. So this is standard enthalpy change of reaction, and these are occurring at standard condition, that is standard pressure and standard temperature. Then standard enthalpy change of formation, standard enthalpy change. So standard means that at standard condition of temperature and pressure, and for enthalpy change it is delta H, and for formation, enthalpy change of formation, that is F, and standard is denoted by this sign, that is standard. So this is standard. So standard enthalpy change of formation is the enthalpy change when 1 mole of a compound is formed from its elements under standard state. Now, here 1 mole of a compound, you have to remember that the highlighted point is 1 mole. So 1 mole of a compound is formed from its elements under standard state. So here we can see that 1 mole of a compound is formed. So this is the enthalpy change of formation. Then 1 mole of a compound is formed, that is 1 mole. But here we can see that 2 moles of a compound is formed. So this is wrong. And for standard enthalpy change of formation, it have to be a 1 mole of a product. Then hydrogen plus bromine is equal to HBr, and this is 1 mole. So standard enthalpy change of formation is the enthalpy change or the energy change when 1 mole of a compound is formed from its elements under standard state. That is, 1 mole of a compound is formed from its elements under standard states, and the elements must have to be in standard state. That is, carbon, its standard state, or it is in the form of graphite. Then oxygen is a gas at room temperature and pressure. Then iron is a solid, hydrogen is a gas, bromine is a gas. So they have to be in standard state. Now, standard enthalpy change of combustion. So enthalpy change is denoted by delta H. Combustion means C. Delta HC, that is the enthalpy change of combustion. And for standard, this is the sign of standard. So this is standard enthalpy change of combustion. So standard enthalpy change of combustion is the enthalpy change or the energy change. So basically heat change or the energy change when 1 mole of a substance is completely burned in excess oxygen under standard condition. So here the highlighted points are that 1 mole of a compound is burned. So for combustion, we know that combustion is the reaction with oxygen, and since it is a standard enthalpy change of combustion or complete combustion occurs, so for complete combustion we need excess oxygen. So 1 mole of a substance reacts with excess oxygen. That means oxygen must have to be in excess. So 1 mole of a compound, 1 mole of a substance reacting with excess oxygen. So the reactant have to be in 1 mole and the oxygen have to be in excess. So here, this is the standard enthalpy change of combustion reaction. There is combustion, so reaction with oxygen, and complete combustion occurs. So for complete combustion we need excess oxygen, and it is the standard enthalpy change of combustion when 1 mole of a substance, that is 1 mole of a substance, is completely bound with excess oxygen under standard condition of temperature and pressure. And what is standard condition? We know that for a standard condition, the pressure is 1.013 into the power 5 Pascal, and for temperature it is 298 Kelvin or 25 degrees centigrade. Then for standard enthalpy change of neutralization. So for standard enthalpy change of neutralization, enthalpy change means delta H, and it is a standard, so standard, and it is neutralization. So NEUT, that is standard enthalpy change of neutralization. So neutralization means that acid reacts with a base to form salt and water. So neutralization is acid reacting with a base to form salt and water, and salt and water. So this is the ionic equation. So only water is shown and the spectator ions are removed here. So standard enthalpy change of neutralization is the enthalpy change or the energy change when 1 mole of a compound when 1 mole of water is formed by the reaction of an acid with an alkali under standard condition. So for neutralization, it is basically the reaction of acid with alkali to form 1 mole of water. So acid reacts with alkali to form 1 mole of water, acid reacting with alkali to form 1 mole of water. So standard enthalpy change of neutralization is the energy change or the enthalpy change when 1 mole of water is formed by the reaction of an acid with an alkali under standard condition. Then to calculate the energy or find the enthalpy change, so we use the formula Q is equal to mc del theta, where del theta is the change in temperature, C is the specific. So del theta is the change in temperature and C is the specific heat capacity, and we have given the value of specific heat capacity in the data booklet or in the data information inside the question paper. So specific heat capacity have a value that is 4.2 or 4.18, and you need to ensure this by looking at the data that is given. So sometimes it is given that the specific heat capacity is 4.2 and sometimes it is 4.18. So you need to look at that which value is given, and by using those values you need to do your calculation. For example, in the data it is given that 4.2. Data booklet it is given that the value of C, there is a specific heat capacity is 4.2, but you do your calculation with 4.18, then this would be wrong. So you have to use the value that is given in the data booklet. So M is the mass of water, so mass is in gram. Then Q is the heat transferred, that is joules. So Q is the heat transferred, M is the mass, and you have to remember that this is the mass of water, and C is the specific heat capacity, and del theta is a change in temperature. Then for Hess's law states that the enthalpy change of a reaction is independent of the part taken, provided that all the measurements are made under standard conditions. That means, let's suppose A is reacting with B to form C. Now, here A and B also react to form D, then D reacts to form C. So here we can see that whether we choose this path or this path, the overall enthalpy change, that is the energy change, that is delta H, is same. So overall enthalpy change is independent or is same unless the experiment is done under a standard condition. That means the enthalpy change would be same, and this occurs when we do our calculations under standard condition, under the same condition. So it is same condition or standard condition. That means the enthalpy change, that is the energy change would be independent or would be the same. That is, whether we choose this path or this path, the overall energy change is same until the measurements are taken at the same condition. Now we would solve the past paper.